Today, in the second part of the nomenclature video, we're going to be looking at how we name covalent and ionic compounds, and how we also write their formulas based upon their names. So the first thing to know here is that we have three different types of compounds. We have type 1, 2, and 3. And as listed here, type 1 and 2 are both ionic compounds. Gotta remember back, what is an ion? What are ionic compounds? Well, ionic compounds are elements that are attracted to each other because of their opposite charges, because ions are atoms with a charge. So type 1 compounds here are ionic, and they're going to be compounds where the cation, the positively charged ion that makes up the ionic compound, can only have one type of charge. It only forms one type of cation. Compared to type 2 is still ionic. However, it can form multiple types of cations because it can have a couple different charges. For example, in this chromium 3 hydroxide, chromium is a cation that can be a +3 charge, or it can have other charges as well, like a +4 charge. And then type 3 compounds are going to be covalent compounds. So covalent is going to be two nonmetals bonded together, unlike ionic is a metal and a nonmetal. So as we move forward here, we're going to be talking about type 1 and 2 compounds first. With type 1 and 2 compounds, there's a few general rules that you want to keep in mind with writing their names and writing their formulas as well. The first thing is that we always write the cation's name first. So that's going to be the positively charged ion first, followed by the anion's name is second. The other thing with the names is that sometimes if it's a type 2 compound, there will be a Roman numeral that goes with the name. And that's just to distinguish what form of the cation we have. So in this case, we have copper 2 nitrate instead of copper 1 nitrate, which would have different properties and respond differently. Now, I like to think of these Roman numerals as kind of the last name of the element copper, and it helps to just distinguish between those two. The other rule that is last is that the charges, the total charges, have to match and balance each other. So here for lithium, lithium on its own has a +1 charge, and oxide has a -2. So we need to multiply the +1 by 2 in order to get a total of a +2 charge, so that the +2 balances to the -2. And we're going to talk about how to do that here in a little bit. With type 1 and type 2, we also have polyatomic ions. And just to break the word down, poly means many, atomic is going to be atoms, and then ions are atoms with a charge. And here you see a table that has a list of common polyatomic atoms. And as you look at this list, you can see, for example, here with hydroxide, that we have an oxygen and we have a hydrogen that are together to make this one ion that has a -1 charge. So we have many atoms together to make the one ion. As you look at the periodic table, you can see the polyatomics here up on the top, but then we can also look here at the transition metals. And this is just one example where the transition metals are split into multiple cations for some of these metals, and that would be our type 2 compounds. Okay? Then also a reminder that our groups, so each group that goes down is going to help determine what its charge is, depending on what is the amount of electrons in its outer valence shell, and then what the atom will do with those in order to either gain or lose electrons. Okay, let's look at some examples with naming type 1 compounds. Here we got ionic, so they're type 1. We have Na and we have Cl, and so in order to name it, it's just sodium chloride. There's no Roman numerals that we need, and so we can just put the name there. Now with this one here, I like to kind of split it apart between our cation and our anions. This one is dealing with a polyatomic, the OH. So I write my cation name first, sodium, and then I find this polyatomic on our chart. So if I go back here, we can see that that is our hydroxide, OH. It has a -1 charge. So then we got sodium hydroxide. Writing the formulas for type 1 compounds is just a little bit different. Same thing with splitting these apart. I like to just draw a line so I know the difference between cations and anions. But this is where that rule of making sure the charges balance to 0 is important. So for potassium, if I find potassium on the periodic table, I see that it's in group 1. So that tells me it has a +1 charge. And then hydroxide, that is one of our polyatomics, and it has a -1 charge. So my +1 and -1 equal 0. So I don't need to do anything else with it. So now I can just write out the formula, KOH. And OH, once again, is the hydroxide. If I look down here, I have potassium, once again in group 1, so it has a +1 charge. And then nitride. Now nitride has a -3 charge because it's in group 5. So these charges do not balance out to 0. So what I need to do is consider what is the common factor that both 1 and 3 go into. And that number would be 3. In order to get 1 to be 3, I got to multiply it by 3. And then I get a +3. And -3, you can think of multiplying it by 1, but really we don't need to do anything. This multiplier is going to become my subscript. So I got potassium 3 nitride. Okay, here is type 2 compounds. Now the difference between this is that the cation can form multiple types of cations, multiple charges. So here I'm going to start with my bromine because the cation, I don't know what form it is yet. Bromide is going to be in group 7, so it has a -1 charge. Now because of the subscript, that becomes my multiplier. So I'm going to multiply that by 3, and I get a -3 charge. Now for iron, there is no subscript here. So because of that, I assume that it's 1. If I assume that it's 1, then over here, this has to be a +3 charge because of the rule where the cation and anion charges have to balance to 0. Therefore, I know that the type of iron this is iron 3. The charge and the Roman numeral are going to always be the same. So if the charge is +3, the Roman numeral will be 3. Why don't you go ahead and pause the video and see if you can try this one out on your own. If you check your answers, hopefully you found the same thing that we did here. One last way with type 2 compounds is going from the name and writing the actual formula from that. So now that we've looked at balancing these charges multiple times together, I'm going to just get you started by splitting the cation and anion up. But why don't you go ahead and pause the video and try to solve these on your own, remembering to balance the charges before you write the formula. If you check your work and check your answers, hopefully they match, and your subscripts, your parentheses, all of that lines up as well. So we've looked at type 1 and type 2 compounds. Now let's take a look at type 3 compounds. Type 3 compounds are going to be covalent. And covalent, remember, is that the electrons are being shared as they are bonded together. For covalent, we are going to be using Greek prefixes. And the prefixes are going to be what's telling us how many of each particular atom we have. So for example, here, the prefix di is referring to our 2 oxygen that we have. There's a couple rules to keep in mind with naming type 3 compounds. The lower group number is going to always go first, and that will keep its regular name. So in this example, carbon is first and it keeps its regular name. The second element's name changes to end in "ide." So instead of writing dioxygen, here we would write dioxide. And then the third rule we already mentioned, and that's using the prefixes to tell how many of each particular element we have. There is one exception to that rule, and that is if the very first element only has one, we leave mono off. That's the only prefix you don't include, is mono on that first one. Okay, let's do a couple examples of these together. So using these prefixes, if we look at this one here, we have 2 nitrogens, so it's going to be dinitrogen, and then we have 3 oxygens. So the prefix is tri, and instead of oxygen, we write oxide, changing that ending. The second one here, we have sulfur, and there's just one of them, but that's the exception to the rule. We don't write mono before the very first one. And then here we got dioxide again. Now when you are going from the name to the formula, you want to look for those prefixes in order to know what the subscript would be. So this very first one, we got dinitrogen. So my nitrogen, I have 2. It's a subscript. Trisulfide. So there's sulfide and tri. So it's N2S3. Go ahead and try this last one. Pause the video if you need to, and then check back your answer. As you check your answer, hopefully you got the same thing as we did here. I hope this video on the second part of nomenclature was helpful. Have a great rest of your day.